All right, so I see some of you guys joining the stream. You're welcome back once again to this section. So in today's video, we are continuing from our past question discussion on quantitative methods, and then we are taking from question number 41. I think we have dealt with the rest of these questions, so we are continuing from question number 41. So from question 1 to 41, we have already dealt with this. So we are just continuing from question 41. So if you just join us, you're gonna make sure to like this video and share it out so that others can also join in that case. So let's start right away in that case. So question 41, correlation is referred to as, correlation is referred to as, correlation is referred to as A, we have a causal relationship between two variables. B, we have association between two variables. C, we have a proportion of variance that two variables share. And D, we have statistical method that can only be used with correlation or research. So here, correlation, we are talking about association between or two variables. Okay, we are talking about what the relationship that exists between or two variables. Is that okay? All right. So let's be guided about that. So that's going to be what option E. That's going to be option E or option E. So I've circled here. Now let's go to question number 42. If two variables are highly correlated, what does it mean? If two variables are highly correlated, what does it mean? It means that here, so let's see, A, we have what? That they always go together. B, that high values on one variable, high values on one variable, high values on one variable lead to high values on another variable. C, we have there are no other variable responsible for the relation. And D, that changes in one variable are accompanied by predictable changes in another variable. So here, which of them is going to be the right answer? So the right answer for in this case is going to be that when it comes to correlation, high variable changes in one variable are accompanied by greater changes in what another variable. So the right answer is going to be for what? Option D. Option D. So let's take note of that. Now let's move on to question number 43. Question number 43 is saying that the strength, into bracket, the degree of correlation between two sets of independent variables, say x and dependent variable y is measured by. So to establish the strength between two variables, we are saying that for us to do that, we use what we call the coefficient of correlation that help us to establish what the strength of correlation between two variables. So that's going to for option what? A. So let's take note of that. Now let's move on to question number 44. The diagram is an example of, so the diagram is an example of what? A histogram illustrating a lack of correlation between tobacco and alcohol. B, a scatter plot illustrating a perfect correlation between tobacco and alcohol. C, a scatter plot illustrating a positive correlation between tobacco and alcohol. And D, a histogram illustrating a positive correlation between tobacco and then alcohol. So here, the right answer here is what? It's a scatter plot because it's illustrating a positive correlation. And how do you do that? To get a positive correlation, you start from here, and that can be drawn. Oh, okay, no. I think it's gonna be something like this, right? So this becomes what we call a positive correlation because at least some of the points are closer to the straight line. We call the line of best fit. Is that okay? So you have some of the pointing. So here, because it's a positive correlation, it's an upward what arrow, upward line indicates what a positive what correlation. So let's take note of that. So here is going to be a scatter plot illustrating a positive what correlation between tobacco and alcohol. That's going to be option what? C, not a perfect, but rather a positive correlation. 45. Which of the following indicates the strongest relationship? Which of the following indicate the strongest relationship? When it comes to the strength of what a correlation between two variables, we are saying that it's ranging from -1 to what positive what 1. Is that okay? So at this point, for us to know if it is positive, it should be from 0 to 1. If it is negative, it should be from 0 to -1. Is that okay? That is in terms of their strength. So either whether it's positive or negative, that is not our business to know which is the strongest. So if it is positive, fine. If negative is fine. So based on this option, you can clearly see that 0.6 is greater than what 0.5 and 0.09 that of 0.2. So whether it's negative or positive still indicates what the strongest what relationship. So you can go for option what C, because it shows that the R is equal to what negative 0.1. I hope that is clear. All right, so that's for question number 45. Option C indicates what a strongest negative correlation between the variables. All right, now let's move on to question number 46. A correlation of negative 0.5 will indicate a scatter plot in which the slope is. So here is what a downward what correlation, or a downward what slope. Sorry, a downward slope. Is that okay? So here, when you have a correlation of negative 0.5, this indicates what a downward slope of correlation. So more like a negative correlation. Is that okay? A negative correlation. That's going to indicate by what we call a downward slope. That's option B, a downward slope. So let's take note of that. Now let's go on to question number 47. A correlation of negative 0.5 will indicate a scatter plot in which the slope is. So we are saying that if you want to have a perfect correlation, all the points on a scatter plot must lie straight on the line of best fit. I mean, it should lie on it. All the points should sit on a straight line. Is that okay? That's where you have what? A perfect negative correlation. But here we say the perfect negative correlation should be what? Exactly what? -1. But where we are having negative 0.5 means at least we have half of the points sitting or lying straight on the line of best fit here. In this case, is that okay? So here we can say that approximately half of the points of the scatter sit on the straight line. That's the meaning behind negative 0.5. We indicate what half of the points of the scatter plot sit on the straight line. Is that okay? So that is what we need to understand when it comes to negative 0.5. So that's going to give us option B as the right answer. If you have any question, you can drop it in the comment section and then I'll respond to it in that case. Now let's move on to question number 48. Question number 48 is saying that a researcher finds a correlation of 0.4, is 0.4 actually, between personal income and a number of what years of college completed. That was a research that was information that the lab researcher was able to deduce from this research. Based upon this finding, he can conclude that a person who attend 4 years of college will have an annual income of $40,000. B, more years of education cause high income. C, personal income is positively skewed variable. Then D, more years of education are associated with what? High income. So here, which of them will signify the best explanation out of these findings by this researcher? We can conclude that here, more years of education are associated with what? High income. We are talking about what? Correlation. Correlation. So we say with correlation, one variable should actually, in terms of the association, if there is change in one variable, it should accompany by a change in what? Another variable. So when the idea here is that based on this finding, the idea here is that if you are to educate for which in reality it doesn't exist, because you can see that in reality some people will go to school but only ask them of their income, kind of, it depends, it varies, but in reality it doesn't exist. Others are true, others are not true. But here we are just making some deductions from the information that we are giving here. Is that okay? So here we can clearly say that if that is so, then more years of education are associated with what? High income, higher income in that case. So we can conclude by saying that the right answer is going to what? Option D. So let's take note of that. As usual, if you have any question, you can drop in the comment section and I'll respond to it in that case. All right, let's move on to question number 49. In calculating R with raw scores, the numerator of R represents. So with raw scores are actually the method that we mostly use as a grading system in most institutions, most especially in educational institutions. We use raw scores a lot to determine the grades for students. Is that okay? So when it comes to raw score, we are saying that the raw score per formula, raw score is equal to the covariance of what the two variable, in this case x and what y, divided by the square root of what the variance of x multiplying the variance of what y. So in this case, they are saying that in calculating r with raw scores, the numerator of r represents what? So here you can say the numerator of r represents what? The covariance of what x and what that of what y. So let's be guided. With raw score, the formula is what covariance of the two variables divided by the square root of the variance of the two variables, each multiply. That's variance of x multiplying variance of what y. Is that okay? So the numerator here is the covariance in that case. So let's be guided about that. So that becomes option what? D. As usual, if you have any question, you can drop it in the comment section. And please make sure to like this video and share it out with your friends so that you can also join us to learn. In that case, make sure to like and share this video as well. Let's move on to question number. Thank you for the joining for today's section. Let's move on to question number 50. Which of the following will not allow you to calculate a correlation? Which of the following will not allow you to calculate a correlation? A negative relationship between x and y. B, a positive relationship between x and y. D, a curvilinear relationship between x and y. And D, a linear relationship between x and y. So which of them will not help you to calculate a correlation between the two variables in this case? So we can finally say that for us to calculate correlation, it should be either a negative, a positive, or a linear relation, but not what? A curvilinear. For curvilinear, you can't calculate what? Or you can't determine a correlation between or two variables. Is that okay? So curvilinear means a curve, so we can use that one as a reference to determination of what correlation. I believe that is clear. Now let's move on to question number 51. As usual, please, if you have any question, drop in the comment section so I'll respond to you in that case. Let's move on to question number 51. If you just join us, you are welcome back to this live session. You're welcome back to this live session. So let's move on to question number 51. The range of correlation coefficient is, so we have already talked about correlation coefficient. We said it is actually the formula, statistical tool or statistical formula that help us to determine what the strength of relation between two variables. Is that okay? And we are saying that by range, it ranges from -1 to what? Positive what? 1. Is that okay? So -1 to positive what? 1. So that is the range between the correlation coefficient. So that's going to give us what? Option C in that case. So let's take note of that. Now let's move on to question number 52. With question number 52, we are asked to use the information to answer question 52 and 43. 53, sorry. So now let's read. The data below shows the number of laptops sold by a sales representative. Is that okay? And number of calls made by the sales representatives. So as and when calls are made, more sales are also engaged. So let's see. So the number of calls made will affect the sales level. Is that okay? So let's see. Let's see. So we have number of calls as the x variable, and you also have number of laptops sold upon any a number of calls that attendant or that's sales representative what makes for that particular period. So question 52 is saying that what type of association be what type of association, you're talking about correlation, exists between the number of laptops sold and the number of calls made. So you're talking about what is the correlation between the number of laptops sold and the number of calls made. You cannot answer this question straight away unless you have what an information to back your explanation or your answer. Is that okay? So by doing that, you should be able to calculate what we call your coefficient of what correlation or correlation coefficient. Once you're able to do that, you'll be able to know that okay, this is a positive correlation, this is a negative correlation, this is that and that. Is that okay? So we can't answer question 52 unless we calculate our correlation coefficient. And how do you do that? Here in this video, I'll try to use a calculator approach to help you to answer this question very fast. So let's go straight to how we use calculator to deal with this question in that case. So now let me zoom to my calculator. Now let me zoom to so on my calculator you can see here. Now for you to answer this question, this is what you need to do. Realize that the number of calls that the attendants make was given here as what 20, 40, 20, 30, 10, 10, 20, and then 30. And then we have the number of laptops sold. Is that okay? So now how do you solve this using a calculator. Now, you can take your calculator and then you follow through as I'm about to start. So on your calculator, you press mode. You press mode on your calculator. For what you can see on mine here is different version altogether. But once you press mode on your calculator, you select start or the number that have a start as an indication, start. So when I select start, for my case, we have a number of info. So once you select start, is that okay? You select an equation that says a plus bx, an equation that says a plus bx, something like this, an equation that says a plus what bx. This is what I'm talking about. Is that okay? So once you select start, right? So once you select mode, you select start as a second step, and then you select an equation that says what a plus what bx. I believe that is clear. All right, so let's do that. So with my case, I select mode, I go to start, and then okay, I think I need to reverse this. So you select mode, you go to start, and then you select an equation that says what a plus what bs. So once you're able to get that, let me raise something here. I was trying to do something here. So once you're able to do that, you get a table for column X and that of what column Y. And even if you are fortunate, your calculator also give you the frequency for that. But if you just have two columns X and Y, that is fine. The value that you see here was what other values I was doing with. So don't please don't concentrate on these values. You are going to use our values in that question. Right. So once you're able to get the table here, this is what you're going to do. You just pick up your informations and then you start key in that case. So I have my information. It's fortunate that you can see, unless I go forth and back, you can see the information for this question, but I have one here that you can use so that you can also have a reference to rate. So the number of calls made is going to be your X values. Is that okay? And then the number of laptops so is going to be your Y values. Is that okay? So with the number of calls made, first one we have 20 for a number of calls. Sorry, we have 20. So you select 20 and you key, and then you come to the Y values too. So with the Y values too, we have 30 for a number of calls made. We have 30 in that. Then you come to the second one, we have 40 for a number of calls made, and then we go to the number of laptops sold. We have number of laptops sold, we have 60, and you do that. And you come to the third one, we have 20. You have 20 for number of lap calls made, and then we have that of 40 for number of laptops sold. Is that okay? All right. Then we come to the next. So the next we have 30. We have 30 for calls, and then we also have the number of calls made as what 60. So you just key on the calculator. Is that okay? And then you come to the next. So we have 10. We have 10. So I'll select 10 and I'll hit on the X values, and then I'll come to the Y values. The 10 goes with what 30 laptops sold. And then I go for another 10. So sorry. I go for another 10, which is 10 for the number of calls made. Sorry. So 10 for a number of calls made. And the laptop that we sold at this point was what? 40. 40. Come in. 40. All right. And then you continue. I think the information was 20. So you continue with the next. So with the next, the number of calls that we made was 20. Oh, I forgot it. Erase this. 20. 20. And number of laptops that we sold at that point was what? 40. 40. 40. Then you continue to, so we have 20. We made 20. Calls that we made in terms of 20 was 3. So you have another 20 here. And then we have the laptop sold to be what? 50. 50. And then the last 20 was, we have 20. And then number of laptops sold at this point was what? 30. 30. All right. Then last one, we have 30 made 30 calls, and then he sold a laptop of what? 70. Laptops of 70. So here the frequency should be 1 1 1 1. If you don't have any frequency, fine, that is okay. But here I'm having a frequency, so I need to fill it, make it 1 1 in that case. So 1 each one, and then here's a 1. So once you're able to fill out this, so first you select mode, and then you select start. Is that okay? And then you move on to select an equation that says what? A plus bx. You select that one, and then I think a table will pop up, and you fill with the values of what? X and y. Is that okay? So this is what I was talking about here. So you can clearly see that we have our 20, 40, 20, 30, 10, 10, 20 here, and then 30 there. And then the number of calls that we made, 30, 60, 40, and those that have already filled. So let's get back to our calculator once again. So once you're able to get this, once you're able to fill the table for column X and that of column Y, you press AC on your calculator. You press AC on your calculator. You press AC on the calculator. So once you're able to press AC on the calculator, you select shift and you locate start on the buttons of the calculator, which is on top of what? Key 1. I mean, the button as key 1. I mean 1. Once you check on top of your calculator, you see start. Just select start. So you select shift and you select start, which is what? 1. So once you select 1, to take you to a number of informations here. So on my calculator, I have data, I have summation, I have variable, I have mini slash mass, I have distribution, I have regression. So once you select 1, you select what? Regression. You select regression. So sorry, I said regression. So we are talking about coefficient of correlation rather. So let's locate coefficient of correlation. That's going to be what? For my case, I have coefficient of correlation to be 3 here. So select coefficient of what? Correlation. Is that okay? Select coefficient of what? Correlation. Coefficient of correlation. Coefficient of correlation. That's why you need to select. So when you select that, I think you should be able to get 0.75 kind of. So 0.75. At least it should be close to some of the answer that we have here. So for my case, when I select R, I'll press equal to sign and then I'll get it. Or when I select R, the answer already pops up. So that's how we use the calculator to solve for the coefficient of what? Correlation. So first, all that you need to do is to, first of all, select mode on your calculator. Once select mode on your calculator, is that okay? You select start, the number that comes with the start, you select it, and then you select an equation. Is that okay? Which is A plus BX. I hope that is clear. And then you key in, the table will pop out and you key in the values of X and Y. And then I think from there, you press AC and then you press shift and you press 1 on your calculator, and then you select the coefficient of correlation. Once you select that R and you press equal to sign, you get your final answer for that. So that's how we use calculator to deal with that. So in our case here, we can say that an answer to this can be more closer towards A, which is what? 0.759, 0.759. So let's be guided about that. So once you're able to know that the coefficient of correlation is 0.759 as an approximation, then we can say that question 52, we can say that what type of association exists between the number of laptops and number of calls made. So we can perfectly say that this is what there exists a strong positive correlation between the number of laptops sold and the number of calls made. When you say it's a perfect correlation, means that all the values will lie straight on the line of best fit. Is that okay? So there wouldn't be any point that will be a bit farther away or just closer to the line. They will lie straight or they will sit straight on the straight line. So since this one is not, this 0.75 is not close to 1 or it's not the same as 1, we can say that there exists what a strong positive what correlation. Because this is positive, so we can say that there is a strong positive correlation. So it could be something like this. The line going to something like this, and then let's say you have your values something like this. In that case, I mean, they will be close. They will be closer to that, something like this. Is that the case? That becomes what we call your strong positive what correlation. So let's be guided about that. So here we can see that option C is the right answer to question 52, and that of 53, it is 0.6. So that's how we go through the using the calculator approach to solve for the correlation coefficient. So if you have any question, please drop in the comment section for this so that I'll know whether you have been able to use the calculator to solve it or not. And I'll know how also to provide the level of assistance you need to solve for this using your calculator. So you're not going to work it out here, but you're using calculator approach to solve for it. So let's take note of that. Let's take note of that. So let's move on to question number 54. The equation for a simple linear regression can be expressed as the equation for a simple linear regression can be expressed as, so you can always express this as what? Y is equal to a plus what? Bx. Y is equal to a plus. So for most simple linear regression equations, we use y is equal to a plus what? Bx, where the y is a dependent variable, the a is the intercept of y, and b is the slope of what? The regression or the equation, and then x is the independent variable. Is that okay? That we use to predict the dependent variable as what? Y. Is that okay? So at this point, we can say that y is equal to a plus bx is going to give us what? Our regression or simple linear regression equation. I hope that is clear. All right. So at this point, we can see that the right answer for 54 is going to give us what? Option B, which is what? A plus what? Bx. A plus bx. So let's take note of that. A plus bx. All right. So now let's move on to question number 55. It said you have to use the information to answer from question 55 to 57. So how do we do that? Given the data below, what is a simple linear regression model that can be used to predict sales? So now let's move on to question number 55. So we are just giving a scenario for this. So question 55 is saying that we have this data week 1, week 2, week 3, week 4, and week 5. And we have the sales that are engaged on or that are made for the various weeks that we have here. So question 55 is saying that what is the value of slope, that's B, of the equation of the regression line for the given data. As I said here, the b is always the slope, the a is the intercept of y, the y itself is the dependent variable, and the x is the independent variable. So let's be guided about that. So it's saying that what is the value of the slope, that's the b, of the equation of the regression line for the given data. So how do you do? So this one, you're gonna use same thing, calculator to do that. Going to use our calculator to do that. It's actually very simple. We're able to get your values very sharp. So we are using the same start approach. We are using the same start approach. So that one too, all that you need to do is to, so if you want to repeat, you select mode, you go to start. I've already done that. So all that I need to do is get my table back. So I'll select shift and I'll go to start. Is that okay? So for me to get my table, all I need to do is get my table back by selecting the table in that case. Is that okay? So here, remember we're giving week 1 up to week 5. So we have 1, 2, 3, 1, 2, 3, 4, 5. We have for S column going to be 5, and then for Y going to be 5. So the week going to represent the X values, and then the sale going to represent what? Your Y values. I believe that is clear. So here, all that I need to do is to fill in the column. So you're gonna change this. So you can say that. So let me fill it using 1. So we can say that week 1 is going to be 1, or the first column is going to be what? 1, and 2 for the second column, 3, 4, and then 5. Remember, we're having this info. So let me clear this off, making it 0, 0, so that we don't add up to our presentation here. Oh, sorry, I think it's not part. So likewise here, let me do for this one too as well, so that we don't make any mistake here. So 0, 0 here, 0 there, 0 there. So remember here too that once you're able to do that with my calculator, because we are having frequencies, I need to also to make the frequency 0, unless it can affect my values. And then you're off and done. So now let's do that of the sales. That's for the Y. So the sales to, we have 150 for week 1, 157 for week 2, 162 for week 3, 166 for week 4, and then 177 for week 5. So you're gonna fill it using that. Remember, you are using our equation A plus what? That's a simple linear regression equation that we are using. So I'll fill it. I know the first week we made a sales of what? 150. We made a sale of what? 150. So 150 filled. It comes to, oh wow, I've erased something from here. Oh, come on. I'm coming. Okay, let me fill this one. So you have 150 and we have 157. We have 162, 162, and then we have 166, and then we have 177. So let me change this one. So here you have already one here already. So we have 2 here, we have 3 here, we have 4 here, and then we have 5 here. All right. So once you're able to fill out your table for X and then Y, you do the same thing. You press AC to get it cleared. Is that okay? And then you select your shift once again. Once you select the shift, you press what? 1 on your calculator. Bottom 1. So press 1. And then once you press 1, we are looking for what? The first question is saying that what is the slope? We are looking for the slope. So you select what? Regression on your calculator. So once you select regression on your calculator, you select what? The regression coefficient, which is what? The B. Is that okay? So you select what? B. So once you select B, come on. Have I left something out? Once you select B, your answer will pop up. Your answer will pop up. So let's see. I think the table here, it should get something like 6.3, not 5.3. So let's see how the table have been so that I can make some corrections for my data values. We have 1, 2, 3, and then 4. So what is missing here? Okay, yeah, the frequency here, 1. The frequency 1 here, I made it 0. So making frequency 1 here. All right. So now you select AC. I'm coming. So once you select AC, select shift and it count to start. Now you locate your regression and select what? B on the calculator, and should be able to get what? Regression, the slope of the equation to what? 6.5. Remember, for my frequency, the last one, it was 0. I should make it 1. So that is why I had 5.3 for the first one. So actually, the right answer should be what? 6.5 using the calculator. So that becomes the slope. So remember, we are using this equation, a plus what? Bx. A plus bx. Is that okay? Right. So here we can say that our slope of the equation is going to be what? Option D, which is what? 6.3. I believe that is clear, right? So once you're able to get that, you move on to question number 56. Question number 56 is saying that what is the value of y-intercept? That is what? The A here. This A here, right? Of the equation of regression line for the given data. For the given data. So how do you also do that? You still have the information there. So what I need to do is to still clear the slope that you have done, select shift and then press 1 on your calculator, and then you locate what? Your regression. Once you locate your regression, you select what? The A on your calculator. You see it. Once you select regression, you should be able to select A. That represents what? The intercept of what? The Y, which is the same thing as A. So once you select A, you should be able to arrive at what? 143.5 as your intercept. So we can clearly see that the intercept of this equation is what? A, which is what? 143.5. 143. So we know that we know B is what? 6.3, and we also know A to be what? 143.5. Is that okay? Now, that's for question number 56. Now, 57 is saying that using the regression line equation for a given data, find the value of y for x equal to what? 10. So now we know that our equation y is equal to what? 143.5 plus 143.5 plus 6.3x. 6.3x. So now we are asked to find the value of y when x is equal to what? 10. So it's a matter of what? Substitution, right? So we can say that y is equal to 143.5 plus 6.3, and x is what? 10. So just substitute 10 in the equation here. Is that okay? So by that, you should be able to. So you can say that y would then be equal to 143.5. And remember, 6.3 multiplying 10 should fetch you what? 63. Is that okay? So therefore, we can say that y should be equal to, so with the calculator, you should be able to get something around 206.5. 206.5. Is that okay? And that should fetch you what? Option B. That should fetch you option B. So that's all for question 57 using calculator approach. So first, if it is a regression question or regression equation question, you select mode on your calculator. Once you select mode on the calculator, you have a set of pop-ups. I mean, a number of content in the table form. You look for start. That's the statistic. Look for start. Once you select start, you move along to select an equation that which says a plus what? Bx. Once you select that, you have another pop-up where you have a column for x and you have a column for y. You fill it with what? Your values, and after that you clear it off by pressing AC, and you select shift on the calculator and press 1, and you locate whatever you want to solve on the calculator, and you should be able to get that. Here we are dealing with our regression. That's why we select regression and select the particular value that we wanted our calculator to solve for us, and we're able to get that. I hope that is clear. All right, so that is that. Let's take note of that one too. Question 58 is saying that a scatter plot show a set of data points that are clustered close to a line that slopes down to right. That slopes down to right. Which of the following values would be closest to the correlation for this data? So we have a set of the that is close or clustered close to what a line that slopes what? That slopes down. So you have a line and it's sloping down. So mean that the line is going to something like this, sloping down towards right. So it means start from here and it slopes down, comes down towards your right hand side. Is that okay? So it's at the top here and then it slopes down. So when you have a line of this nature, what is it telling you? So this is what we call a negative what? Correlation. This is a negative correlation. This is a negative correlation. So he's saying that which of these numbers here represents a slope or a line that slopes down towards right. So we can say that this is what? A negative what? Correlation. And a negative correlation per this information here. And he's saying that he also give another information here that these points are clustered close to the line. So it means that it is closer to the line of best fit. Is that okay? And then we should be able to, by this information, we should be able to select what? The strongest what? Negative correlation. And in this case, it should be what? Option what? D, as what? Negative 0.8. Because it is clustered. It's saying that a scatter plot shows a set of data that are clustered close to a line that slopes from down towards right. So we are talking about the closest word relationship. I mean closest, and you made that one clearly here that which of the values would be closer to, and that should be what? The strongest negative correlation as well, negative 0.80. So let's take note of that. So it's going to be option what? D, and this is a negative correlation. All right. Let's move on to question number 59. A regression, a linear regression equation has b to be what? 2 and a to be 3. What is the predicted value of y for x to be a? So we know that for regression equation, y is equal to what? A plus what? Bx. And then we have been defined that y is equal to, sorry, we have defined that b is equal to 2 and a is equal to 3. So a is substitute 3 here, and we know b to be what, 2x. So once you have this equation, you are saying that what is the predicted value of y for x to be equal to what, 8. So we can say that at x is equal to 8, therefore we can say that y is going to give us what, 3 plus 2. We know x is what, 8, so it's actually 8 here. So therefore we can say y is going to give us 3, and we know 2 multiplying 8 is going to give us what, 16. So therefore we can say that y is equal to 3 plus 16 going to give us what, 19. So that's going to give us option what, B. So once you have this equation, you are good to go. So let's take note of that. Now question number 60 is saying that regression analysis is saying regression analysis what? So what is regression analysis? So in this case, regression analysis help us to determine the nature of the relationship between two variables. It helps us to determine the nature of the relationship between two variables. It doesn't measure growth. It doesn't establish cause and effect. It helps us to establish what, causation, but not effect. It doesn't add effect to it. We are just interested in what, causation. And since we have cause and effect here, it's a different ball game altogether. So that becomes an option outside the box. Is that okay? And this says I measure the demand for a good. No. So you can say that regression analysis is used to establish a relationship between two variables. It talks about the nature of what the relationship between two variables. And by that, it helps us to determine, help us know the cause of one variable in its effect on what, another. Not necessarily in effect, as I was saying here, but then where one variable changes, what is the cause of that variable changing? That's what I'm trying to put across here. So regression will help us to establish the nature of the relationship between what, two variables. So let's take note of that. Not a cause and effect, but regression help us know causation of why a particular variable is what, changing, but not effect. So let's be guided about that. So we can say that option B is the right answer to regression analysis in this case. Any question? Please make sure to share this video, like it as well, so that others can also join in that case. Now let's move on to question number, that's section B, question number 61. But then we're giving some information to read out here. Now you have to answer all questions in this session. Shade A or B on the scannable sheet to correspond to true if it is A and false if it is B, respectively. You should also indicate your answers beside the question. Okay, that was the instruction that was given then. By then, those who answer these questions for that particular year. Now, question 61 is saying that the sign of the first derivative is irrelevant for the test of concavity. The sign of the first derivative is irrelevant for the test of concavity. We say for you to test for the concavity of any function, that's where we test whether we have what, this function is a maximum function, this is a minimum function, or is a function at inflection. So he's saying that the first sign, that's where we have our dy over dx. We use the first derivative as dy over dx to test for the concavity of what, a function. If that is true, let me see. If that's false, let me see in the comment section. So, which is it true or false? Is it true or false that dy over dx help us to know whether the function is a maximum or a minimum or at a point of inflection? So, is it true or false? Let me see in the comment section if you have an answer to this. If you have an answer to this. So I'm waiting. 1. I'm counting out to 5. 1, 2, 3, 4, and then last one, 5. I haven't seen any comment in here. Wow. All right. So here we are saying that the first sign, which is what, the first derivative for, as indicated here, is irrelevant for test, and that is true because we don't use the first derivative to test for concavity. Actually, we find the second derivative that will help us know whether this function is a maximum, a minimum, or a function at the point of inflex. So let's be guided about that. So here we can say that 61 is what, true. So that's going to be shaded as what, A, as true. Is that okay? So here it's irrelevant. All right. So let's move on to question number 62. Question number 62 is saying that a point in the domain of a function where the derivative equals 0 is called a critical point. What is a critical point? Critical point is the same thing as a turning point or a stationary point. Or is that okay? The turning point or the stationary point, or the point where the curve changes its direction. The curve changes its direction. So they are the same. They are just alternative name for this that we are talking about. You are saying the point in the domain of a function where the derivative equals 0 is called a critical point. And we can say that at the first derivative, we say that set that divided by dx to be equal to what? 0. And that's what they are saying here, that the point and domain of a function where derivative equals 0 is called a critical, and this is true. Critical point is saying that the turning point or the stationary point. Is that okay? So at this point, we can say that 62 is also what? True. So it tells us that it is what? True. So you shade what? A, or you have your tree. I don't have space for it, so that's why you see me writing here in that case. So this statement is also what? True. True. So you shade A on your scannable sheet, assuming if you are the one answering this in an examination condition. Question 63 is saying that if f double prime is this, f double prime of A is greater than 0, then it means the function is a converse and the graph of a function lies completely above a tangent line s equal to A. Now, when it comes to these curves, we have what we call a concave curve and then a convex curve. A concave curve is a curve in a minimum form. So when you have a curve of this nature, we call it what? A concave up curve. Concave up, concave upward. A curve that is being concave what? Upward. Is that okay? So we call it a concave. But when you have a curve of this nature, we call it what? A convex. That's a down U. Is that okay? Or upside down U. But when you have an open U, it becomes a concave. When you have an invert, or let's say inverted U, that is concave downwards, we call it what? A convex. Is that okay? So here we call this a convex, and we call this what? A concave. A concave. So with a concave, you see that you have what? Your line s equals A, where the concave sits on that line. But with the convex, you have where the curve lies below what? Your line x is equal to what? A. Is that okay? So here he's saying that if f double prime is greater than 0, we said for us to establish a concavity of what the function, we use a second derivative. I mean, that one should even give us a clue before we conclude that whether this concave I'm talking about even will comes in. So if you have f double prime to be greater than 0, we said that at that point, it is what? A minimum word function. We said for us to establish whether a function is a minimum, maximum, or inflex. If it's a minimum, then we are saying that our d squared y over what? ds squared should be greater than what? 0. And which is the same thing as f double prime. And they are saying that if f double prime of a is greater than 0, it means the function is convex. And that's false. But we are saying that for a function to be convex, the the squared y over ds squared, or f double prime, should be less than 0. So if actually a function, a second derivative of a function is greater than 0, you should tell us that it means that the function is what? A concave, not a convex. So if you're saying that it's a convex, at this point, you can even conclude without reading further information that this is actually a false word statement. It's a false statement because for f double prime, we are saying that the function should be what? A concave. And the graph of the function should lie completely above. As you can see here, you see that the graph is lying completely what? Above here. You see the u is lying above what? The x is equal to what? A, and not below. So if that is okay, then we can say that this is a false word statement. False statement. So you shade what? B or false. Is that okay? All right. So that is that. Then question 64 is saying that if f double prime of a is less than 0, it means that the function is concave. So here too is what? A convex, because this is what? A maximum function. You say for a maximum function, you should have what? An inverted what? U. That's concave down, concave down, concave down. So you have something like this. You have something like this. you have your line, you have what? Your curve. So mean that at that point, your converse curve will lie below your line x is equal to what? A. Lie below your line x equal to what? A. So at this point, we call it a converse curve, not what? A concave. So this is also what? False. So you shade what? B. I hope that is clear. All right. So moving on to question 65, is saying that if f double prime of A is equal to 0, then we can say that the test for concavity is conclusive. The meaning of conclusive here means that you're trying to tell us that if you have f double prime of A is equal to 0, the test concave, it means that it's trying to tell us that at this point, we can still make a decision to determine whether the curve is a maximum, a minimum, or at the point of inflection. But at this point, if it's conclusive, we can't make a decision. You can't, it's not decisive, because it has already been saying that f prime of s equals 0. Means that here it has already taken a different formula altogether. Means that here f double prime of A is equal to 0 is what? At the point of inflection. So here we can't use it to determine the concavity of for the function. That's the meaning of the conclusive here. That we still have an option to determine whether this function is a minimum, maximum, or converse. Minimum, maximum, or sorry, point of inflection. Is that okay? So here, since you are saying that f prime of is equal to 0, here so that we can see that as a point of inflection. We don't have any other information to determine whether this should be a maximum, minimum, or point of inflection, because it's already pair what we can see here. It has already been determined by itself that this is what a point of inflection. So we can't use this information to make any other decision as to whether we can decide whether it's a maximum, a minimum, or inflection. So here is also what? A false statement. Here is also what? A false statement. That's what in shade what? B. So be guided about that. Question 65 is saying that, sorry, 66 is saying that if a function is strictly concave or convex, then there will be a multiple maxima or minima. So if I have a function of this nature, here you only have what? Your local what? Your local what? Minima. Your local minima, or your local what? Minimum. Is that okay? Your local minima. But where you have a curves of this nature, let's say we have this, or let me put it in this way so that you appreciate what I'm saying. Or let's start like this. Let's start like this. So if I have this curve, I can see that this, you see something here. Let me raise something so that you see. I want to make it a perfect so that you understand what I'm trying to put across here. Oh, I don't think it can be. It you raise all. Okay, so you see that. Okay, well, let me raise it so that you get what I'm trying to put across here. So let's say I have a curve of this form. A curve of this form. Something like this. So once you see this, this is a combination of maximum and minimum curve put together. We are saying that at this point, we can call this point as what? Your global what? Your global maximum. So let me call it as what? JM, your global what? Maximum. Why is it called global maximum? Because global maximum on the curve has the highest what? Peak. Has the highest peak. So you can clearly see that here, my JM here as global maximum is higher than this one. It's higher than this. Is that okay? It's higher than this. So here becomes what? My local what? My local maxima. So local maxima is far in terms of the peak, has a smaller peak as compared to the global maxima. But when it comes to the, so here too, we can say that here is our local minima. Our local minima, is that okay? So let's say local min and local max and global max. And here we can say that here also at our local what? Min. So our global min. Because we say for global, it has a highest peak on the curve. But the question is saying that 60 says that if a function is straightly concave or convex, then there will be multiple maxima or minima, and that is false. Because if a function is treated like what you see as a local minimum or minimum function here, do you have any other thing that we can determine that we have a global maxima or global minimum or those kind of? No, you have just what one turning point here, and at this point we can finally say that it is what false. We won't have any multiple. But if we're having a curve of this nature where you have this curve, as I've already indicated here, that's where we can have a number of what points here as what our local maxima, local minima, global maxima, and global what minima. Is that okay? So here, because it was strictly concave or so here's just a concave, and if it's convex, just have what one point, whether it's a global maxima or a local maxima. For that one, we are not just interested, but then we are saying that it should be just what one. It should be just one. So let's take note of that. So that's also what a false statement. 60 says also a false statement. So we should what B in that case. Let's move on to question number 67. The presence of only one maxima or minimum of a function is called a global maxima or minima. So when you have a maximum or minima, as I've already indicated here, you can it depends on the peak. Depends on if you are to comparing. If you are comparing, then we can say that if let's say was these two here, if you are comparing, we can say that we have what this to be a maxima or what, a minima. But when it is there, we can say that this is a local maxima or this is a local minima or this is a global maxima or global minima. But other we can say that this is a minimum function or what, a maximum function. When you add that global maxima or local maxima, the two comes in where we have what a number of these functions coming together. That's where we can determine that at this point it's a global maxima, at this point is a local maxima, or at this point is a global minima, or at this point is a local what minima. Is that okay? But when the curve is just there, like we call it what a maximum function or a minimum what function. I hope that is clear. So at this point too, the presence of only one maximum or minimum, one maximum, sorry, or minimum of a function is called a global maxima. It's not true. We just call it a maximum function or a minimum function. But if where we combine a number of these functions, that's where we can establish our local maxima and then our global maxima or minima any other way around. So here too, we can say that is also a false statement B. Perfect. Right. Now, question 68 is saying that in applying the weighted moving average of forecasting approach, WT represent, that's what you have, what weight for the time, represent the weight given to a time period, as I was saying. And all the weight must add up to one. And that is true. So all the weight that you applied on these what previous what data to forecast for the future, we are saying that all the weight when you apply it on it, the weight should be add up to what one. So your weight should be add up to one. So if your weight is above one, then you are not using what a weighted moving average. We are using a different method we ourselves we don't know. So always the weight must always be add up to what one. So here is true. You shared your A and tell us that this is a true statement. Is that okay? Now, question 69 is saying that an independent variable is also known as a response variable. We said an independent variable is a variable that helps us to predict the dependent variable. So independent variable can also be called a predictor variable or an explanatory variable, not a response variable. Response variable is called the dependent variable. It changes as and when the independent variable changes. So response variable is the same thing as dependent variable, but not an independent what variable. So response variable is the same as dependent variable, but not an independent what variable. So here is also a false statement. It should be. Perfect. Good. And then question 70, last question, is saying that regression is used to determine whether a linear relationship exists between any two variables, and correlation is used to determine the type of relation. I said earlier on one of our presentation that we use regression to determine the type of what the relation that exists between what the two variables, but correlation help us to determine what the linear relationship. So here it's just a turnaround definition. Instead of we saying that regression is used to determine the type of relationship, we are saying that regression is used to determine the linear relationship, and we are saying that correlation is used to determine the type of relationship. We have just interchanged their definition here. So here too we can say that this is also a false what statement. This is also a false statement. All right. So that brings us to the end of the 70 questions that we started. So we have already covered a number of them on this channel. So once you check the quantitative methods on this playlist of this channel, you're able to see a number of past questions you have solved so far on this channel. So thanks once again for joining this live session. So I'll catch you up on other time where we discuss other issues on this channel. So thanks for joining once again. So if you have any question, even if we end, you can still drop it in the comment section and I'll respond to it in that case. So in absence of any question, then I'll end for today. I'll end here for today. All right, so I'll see you. Bye bye.